Well, I have one. Well, as far as I understood, your language model is modeling the music sequence in a prefix-based way, right? So it takes into account the symbols that go before. I mean, if you are when you're predicting the symbol at time step t, it takes into account the t minus 1 to 1. But in music, there are a lot of non-sequential relationships, or well, not non-sequential, but it's not only the prefix what matters. For example, in text, we usually assume that the prefix is the most important part for the next character. But in music, there are some clues that can be after the symbol that you are going to predict instead of before. So
now,
do you have any idea of how that could be modeled or approached?
I mean, this is an interesting question, definitely. It's not something I had thought of, mostly because in this work in particular, we're not only constrained by what the most optimal model of music is, but rather how the architecture works. So in this particular context, I don't think it would make much sense because we don't really have a way of having future information, so to speak. Maybe you're referring to the fact that we could add transformers in a more contextually based learning, perhaps? Is that what you're hinting towards?
Well, no, I wasn't thinking of that, but it's right. With the transformer, you have like everything at the same time. No, but I was thinking maybe you could do rescoring so that you have like an initial hypothesis, and then you have the future, maybe a wrong future, but for example, this idea was because I saw, yeah, now you are predicting the next token using the optical and the language model at the same time. So of course, then you only have the symbol that you already predicted. But I saw in some HDR or OCR approaches that they do rescoring so that they have the full hypothesis, and then they rescore the probabilities before the final decoding. But I was thinking of that because, for example, the slur, you show some inconsistencies with the slurs in some of your examples, and I was thinking that maybe at one point you miss the start of a slur, but afterwards you're very confident that you have a slur end. So at some point this slur start could have been predicted with the confidence that you have a slur end afterwards. I don't know if this makes sense.
Yes, and now I think I get your question, and it's actually a really interesting matter. The problem with this particular architecture, however, is that for sequence-to-sequence models, in the output, you require the token input. We do not use the features, we use the token. And this is a problem because if you want to try to do a rescore of the entire prediction, you will need to have the whole distribution with the context itself.
Well, you may have a word graph, something like that. Like you don't stick only to the best token per step that you, or something like beam search, that you keep some of them, or the best per. I don't know, that I was just brainstorming here the idea in order to incorporate like future, well, not future knowledge. What I mean is that in music, maybe in some parts the prefix is not the only thing that matter. For example, for if you want to comply with the time signature that you predicted, you need to know as well the next tokens until the bar line, something like that I was thinking of.
Yes, and another point was that we assume that part of this, there's going to be an unslur information is going to be recovered by the bidirectional RNN next to the feature extractor. That's the other point. And the problem is that even if you wanted to do a rescoring of your output sequence, you would need to have you would need to be able to predict a longer sequence than you are predicting by default, so to speak. Because the problem about sequence to sequence is that unlike CTC, you have as many predictions as you need, not more, no less. Hence, if you have to make an insertion in your output, you would need to do another inference step. So for this particular model, I think it would be very hard. However, for transformers, I think it's something that makes sense. And in this direction, I was thinking that maybe beam decoding and techniques that I think they are also used in CTC. Correct me if I'm wrong.
Yes, yes.
So maybe in this context, they make a lot more sense if you can do the entire prediction in one step. But for sequence to sequence, I think it's difficult, but maybe someone has delved a little bit more into the matter.
I'm not sure, because with CTC, you have another problem is that, I mean, in the sequence to sequence, you have one token and only one per time step. But in CTC, you don't know how many frames your token will take. So you can have many arrows in the word graph starting from the same vertex. Well,
yes,
Alex,
it might not be easy either way.
well, I just wanted to, I mean, bring the idea of changing the way of modeling the language model. Just, you know, ideas.
Yeah,
that's what a discussion is for.
Okay, I have a question because I have this feeling we're seemingly transitioning into the panel discussion. So I actually would like to come back to the first paper from this discussion and have basically two small questions. The first one is, did you compare your the way how you detect staves and stuffs to some of the existing models, deep learning models that do the same thing? Are you aware that there are some models that have tried this before?
So no, I haven't done that yet. And in fact, one of the kind of next steps I think would be to do that. Yeah, since I didn't look around very carefully. So actually, I would be if you have any specific ideas, I'd be pretty interested in seeing how different algorithms compares with our current data set, and also how the algorithm that I developed kind of works against others.
Okay, so I can just point out that last year there were some papers. So if you just go to previous editions from WoRMS, you can find at least one or two papers on this regard. The second question that I have, which I would say is even more interesting, because I think your application is a fantastic example of a real life application. Yeah. Because I have a feeling that here in this academic space, people are like trying to improve this, improve that. Whereas it seems like the key that makes your application so successful is that it is easy to correct the mistakes and it's kind of fun to use. So do you agree with this, or what is your insight of building this application and actually using it in some real life application cases?
Yeah, no, I think that's a really good point. And it was in fact one of the main emphasis that we had was, how do we make this experience very easy to use? So from a UX, from a user experience standpoint. And what's interesting there is it led us to make certain design decisions. For example, I didn't want everyone to correct a mistake. I didn't want someone to have to like pick 4 corners of a bar, and of course that's more general, right? Because there might be page skew and stuff like that. But the idea of, oh wait, first let's just find the system, and then identifying bars within the system is just a single click, simplifies. It's of course a simplifying assumption, but it works great, for our application. So I think that one of the sort of the trade-offs you get into when you're making a real application is this kind of thing. it doesn't need to be perfect, right? In fact, it needs to be exactly the right technical solution for what we're trying to do. And so that's what that's where we ended up. And it was really heartening to see that people could, someone could take a 200-page score and go through it in like, a half hour and have the whole thing just be, or less, maybe, 15 minutes just to have, and the whole thing is done. So yeah.
It's fantastic. Yeah.
Okay, any questions for the speakers of this session? Because I mean, I have a lot, but I would like more people to join. If not, I have one for Fran that I could not make before. You mentioned your I think regular tree grammar for the truncate. I guess this is something that you manually build. I mean, the rules and everything. And at the end of your presentation, you mentioned that you want to expand your approach to other instruments. And I would like to know how much of the effort that you spend developing your grammar for the drum kits is you can take to other instruments. And because for me, I mean, I don't know a lot about this, that I think it's difficult to reuse, right? So the final question, sorry, is how scalable is this approach to adapt to other use cases?
Yes. So most of the case studies that we have conducted so far are about monophonic extracts, and we have several grammars for these cases. And actually, the grammar that we used for drums was designed for drums, and I think I don't think it's usable for other case studies, but it's not such a big model actually. So it was actually not trained whatsoever for that case study. It was just manually built, and there were some weight values for the grammar rules, which were actually just chosen a bit arbitrarily. The idea is very simple: that you want to evaluate the complexity of a score, and you just count complexity of 1 for each symbol. Okay. And you add some complexity for the time division, like tuplets are a bit more complex than tuplets, like triplets, for instance, are more complex than a division by 2. And that's it. And with that, we obtain already satisfying results. So we didn't try to go further. Yeah.
But now you have data that fulfill the grammar, right? So shouldn't be easy to re-estimate, for example, the weights using something like maximum likelihood principles? Yes. Maybe that doesn't change much, so it doesn't.
Yeah. Yes, indeed. In that case, we could not. We did some weight learning for the weight values in the monophonic cases based on the corpuses of scores. That's something we did before. But we could not do that for the drums because we had no prior examples. We had no scores at disposal for this. Okay. We did not find a dataset of drum scores. I don't know if it's so common, such a common thing.
No, maybe not. Well, more questions for the audience because I have more again, but I don't want to monopolize the discussion. And if not, well, at least one question more for Fran is that, for example, Pau presented an approach to use a language model to improve a recognition model. So my question is, you are now dealing with electronic drum kit. I guess it's because you already get the MIDI file from the interpretation, but could your model be used for improving the automatic music transcription when you have for example, a drums recording?
Yes. Yes, maybe that's something we have not looking at so far, but yes, that's the idea I presented at the very end as a perspective of end-to-end drum transcription from audio files to score. Then in that case, it would make sense to try to integrate the language models that we are using for the audio data transcription.
I think if you have a regular grammars, that should be, well, I wouldn't say straightforward, but there are mechanisms for combining regular languages with optical models. So,
but in our case,
it would be more difficult with other kind of languages.
Yes. So one thing is that, as far as I understood, Pau, you used languages which were language models that are sequential, going from one node to the other. And in our case, we use hierarchical languages. So the purpose of the language is to describe groups of notes, like in rhythms, when you group some notes with the beams. And so that's also the idea of parsing, that giving you these groupings. So I don't know if it's such hierarchical models, it's so easy to use to combine with transcription audio for audio transcription.
I feel like a tool like this might be useful once we have an AST of our final music score or something, in order to enforce plausibility of the score, because I would personally assume that a score is written in a human readable way. Henceforth, I would assume that the groupings would need to make sense according to some of the rules. So maybe in this context, it might be useful. But since we have the output for our model is basically the sequence of tokens, we need this intermediate parsing step beforehand if we wanted to use it. So I see some uses.
Okay, interesting. Thanks.
I think it will also depend. The tokens that you have in your grammar must be the same that the tokens that the previous model is predicting. Otherwise, it's much more difficult.
Yes, of course.
I mean, they have to share the language, and that's something that maybe in your case is not that easy.
In this case in particular, no, but it goes into the discussion that I brought earlier, that if we can standardize these intermediate representations, we can basically make all the OMR works interoperable, which would be interesting for contexts like this, where there is a piece of research that maybe wasn't initially devised for regular OMR, but can be used nonetheless.
Yes.
Okay, I think, I mean, the time, the schedule was to have this session till 4:15, but I think if somebody wants to bring up something, it's okay as well. And if not, please let's thank the speakers of this session for their very interesting talks. Thank you very much, Eran, Tao, Florent.
Thank you very much.
And the colleagues that co-authored the contributions. And so, I think we can move on to the closing session.